Hello everyone, I'm Mona, and we are here together in the MTEXTILER channel to learn what common fibers are, identify them, and learn about their properties. So stay with me. The 4 parts of fiber identification are as follows. 1. What is fiber? 2. Categories of fibers. 3. Main properties of fibers. 4 types of yarn production systems. In this part of the lesson, we are dealing with main properties of fibers. Let's get started. Fiber length. The first property we examine is fiber length, which is very important and determines the type of spinning system, as well as giving fibers properties that are followed by the yarn and fabric. The longer and more filament-like a fiber is, the smoother and shinier the handle will be, and the shorter the fiber, when participating in the yarn structure, the more it will need to be properly entangled in that structure to have less hairiness. However, shortness of fibers can also give them a fluffy property, which also has its own applications. In this slide, regarding fiber length, it is written, length is one of the most important characteristics of a fiber and determines the properties of the yarn, and the length range is very important in staple fibers. What allows fibers to participate in approved spinning systems is their length. The shorter a fiber is, the less ability it has to take part, and if it is too long, it will no longer be suitable for that system. Therefore, fibers, on average, and regardless of their type, must follow the system designed for them and the accepted length in order to be able to participate in the structure of yarns. The next slide is about the cross-section of fibers. Just as we examine fibers longitudinally, we also examine them in terms of cross-section, because the cross-section can affect longitudinal properties. The cross-section determines how the fiber reflects sunlight and how it appears, matte and dull, or bright and shiny. The smoother and more reflective the fiber's cross-section, the better it can reflect light and appear shinier. In silk fibers, due to their triangular cross-section, we can have shiny silk fabrics. Of course, this is one of the reasons silk fabrics look shiny. The cross-section also affects how fibers are positioned next to each other in the yarn structure, and the uniformity of the yarn can also be a function of the cross-section. It is important to note that each property and parameter of fibers can play a specific role in the characteristics and structure of the yarn, and depending on its intensity and effectiveness, its contribution may vary. Sometimes the intensity of one property is so strong that it neutralizes the effects of other properties. Different fibers, depending on their type, have different cross-sections. For example, cotton has a bean-shaped cross-section, viscose has a star-shaped cross-section, silk has a triangular cross-section, and synthetic fibers, because they are extruded from a spinneret in their specific spinning processes, can have circular, triangular, or other cross-sections, creating different properties and characteristics. In this slide, regarding the fiber cross-section, it is stated, the type of cross-section of the fibers in terms of their arrangement and reflection of light, etc. Silk has a triangular cross-section, cotton is bean-shaped, polyester is circular, etc. Fiber fineness. Fiber fineness, whether in short staple fibers or filament fibers, can have a significant effect on the fabric handle, yarn uniformity, and the way it interlocks with other fibers. In natural fibers, fineness depends on the type, breed, and place of growth, while in synthetic fibers, it relates to the production process and the type of granules used. Fiber fineness is a factor influencing the yarn count, saying the finer the fibers, the better the yarn, and ultimately, the fabric, is not necessarily true. We must first determine the end use of the final product and then decide on the appropriate fiber fineness accordingly. In the slide, it is stated that the fineness of the fibers affects the fineness and uniformity of the final yarn. Fine fibers also have a softer feel. As shown in the figure, The effects of fineness are given assuming a circular cross-section. The important point is that if the fibers are excessively fine, it may decrease strength, especially in cotton fibers, which contain a hollow inside. This could indicate that the fiber is immature and has not fully completed its growth and production process, thus being unsuitable for participating in the yarn structure. For learning about the properties of cotton fibers, I recommend watching the previous video titled Category of Fiber. Therefore, every fiber property has an optimal range, and being below or above this range can make the fiber unsuitable for yarn production. Fiber strength. In this slide, it is stated, fiber strength has a great impact on yarn strength, and stronger fibers can have a higher dry state. Fiber strength depends on the structure and chemical bonding of its molecular chains, both in natural and synthetic fibers. As we discussed earlier regarding amorphous and crystalline regions, in this section we will focus more on it. When molecular chains are aligned and ordered, they form crystalline regions, which are strong and rigid. When molecular chains are randomly arranged next to each other, they form amorphous regions, which have high moisture and dye absorption capacity. No fiber is 100% crystalline or 100% amorphous. The percentage of each region determines the overall characteristics of the fiber. A high percentage of crystalline regions results in high strength, but low hydrophilicity. A high percentage of amorphous regions results in better moisture and dye absorption, but lower strength. An important note, having too many crystalline regions can remove the material from being a spinnable textile fiber. We must also remember that in the textile industry, each property has an upper and lower limit, and beyond these limits, the material will no longer be considered a fiber. In the next slide, we will discuss another fiber property called elastic recovery. In its description, it is stated that it is the force with which the fiber is stretched and returns to its normal state. This property is more relevant in elastic fibers, such as spandex, but blending them with other fibers or yarns can transfer part of this property. It also depends on the internal structure of the yarn and the way the fiber has been spun, as well as how its molecular chains are arranged. In fabrics where we need the yarns and fabrics to retain their appearance after use, the presence of elastic yarns and fibers is essential so that the overall structure can return to its original state after each stretching. Every fiber has a certain limit of elasticity. If it exceeds that limit, it will not return to its original shape. The highest elasticity is seen in spandex fibers, and other fibers with lower percentages of elasticity when stretched beyond their elastic limit will either break or deform. The next property is fiber luster, for which the explanation states, it depends on the nature of the fibers and their cross-section and the additional operations on them, such as cotton mercerization and converting the cross-section of the bean into a circular one. Having more crystalline regions, in addition to providing higher strength, also improves light reflection, contributing to the luster of the yarn and fabric. Thus, every property plays its role in the final characteristics of the fibers and yarn. The next slide is about moisture absorption, which states, the fewer crystal points in the fiber, the more water can enter the fiber structure. The more other materials, such as dyes, can enter the fiber, and the more natural fibers absorb moisture. Again, when examining fiber properties, we go back to its internal structure. The greater the proportion of amorphous regions in a fiber, the more water and other substances can penetrate the fiber's structure. For example, in cotton, the moisture conditions during cultivation and bale storage can even affect the weight of the sold shipment. Heavier in humid environments, lighter in dry environments. So, attention to fiber moisture absorption is very important, as it depends on the presence of more amorphous regions in the overall structure of the fiber. Some fibers, such as cotton, are also spun at specific temperature and humidity conditions. The absence of proper humidity disrupts the spinning process. For further learning, stay with us. The next slide is about fiber cleanliness, in which it is stated, "The cleanliness of fibers, especially natural ones, is a crucial factor, as neglecting it can damage the spinning system and also affect the appearance and handle of the final product." As you can see in the image, fibers of different types have environmental impurities, and if not properly cleaned, these impurities may still be visible in the final product. In fact, fiber cleanliness is more critical for natural fibers, as they may contain impurities that can also affect the final product. For cotton fibers, this can include husks, dust, and natural waxes. For wool and silk fibers, protein-based grease can be very problematic, as these substances can prevent dyes and other necessary materials from penetrating the fibers. Therefore, we must use certain chemical and physical cleaning methods, but they can also cause problems for the fiber structure. Chemical cleaners can expose the fiber to degradation and make it unspinnable. Physical cleaning, which removes impurities from fiber bales, can result in the loss of healthy fibers along with the impurities. Thus, it is essential to use a well-functioning and efficient system in spinning to ensure properly cleaned fibers free of any impurities. As seen in the figure, a final fabric product, due to improper cleaning, can contain small particles. These impurities prevent the fabric from being evenly dyed. In the next slide about static electricity, it is stated, "It is created by the friction of fibers against each other, causing the fibers to disperse and move away from each other." This factor is more of a concern during the spinning process than in the final product, because if not controlled, it can cause fires and disrupt the spinning process. During spinning, special oils are used to address this problem. However, in the final product, especially if it is a garment, it can also reduce the beauty of the fabric by affecting its appearance and drape. Now we move on to the next slide. Regarding this property, it is stated, curling of fibers. The longitudinal structure of the fibers affects the entanglement and hand feel of the fibers. This property is entirely dependent on the intended end use of the yarn and fabric. In synthetic fibers, curling can be created by mechanical crimping, heat setting, chemical crimping, or bicomponent fibers. In natural fibers, crimp is inherently present and varies depending on the fiber's breed and the place of cultivation and growth. The fluffier and more crimped a fiber is, the fluffier the resulting yarn and fabric will be. Now we move to the last and most important property, the reaction of fibers to fire, to determine exactly what type of fiber we have in hand. In fiber identification, this is one of the methods. Other methods also exist, which require a laboratory environment and the use of chemicals or microscopes. However, this is the simplest and most accessible method. You only need fire. Bring the fiber, yarn, or fabric close to the flame. By observing the ash and smelling the odor, you can detect what you're dealing with. Of course, regarding fabrics and yarns, it is important to note that some are blends of different fibers and may display two combined reaction patterns when exposed to fire. So now, simply remember these properties. Gather 10 or more pieces of fabric or yarn around you. Start burning them and check for the properties described in the slide. You will then easily identify them, and over time, you will be able to recognize fabrics and yarns made from fiber blends as well. Thank you very much for staying with us until now. Don't forget to subscribe to our channel and hit the notification bell for more learning.